Quantum computing is the next evolution in computing, and it's very different from what we're used to. If you think about the evolution of computing today, as we needed to process more data, we made faster and faster computers. And the analogy I would use is that we went from airplanes that could move somebody across the country in a few hours, to rocket ships that could get somebody to the moon or Mars in a few months. But the limitation has always been that if you want to go 1,000,000 miles in 1,000 hours, you have to be able to go 1,000 miles an hour. If you want to go in less than that, you have to have a faster rocket. And there's only a certain speed that rocket can go. With quantum computing, it's like the Star Trek transporter. It's not a factor of how far you want to go, it's the beam strength. And then the person is there instantly. And that's really the key differentiator. You have to think about computing in a completely different way. Now, they're not good for all applications. Quantum computers aren't going to replace your desktop. They're not going to replace supercomputers. But they are going to do things that all the computers on the Earth combined today could not do. They're going to do them in an instant, like factoring keys for encryption, for example. Quantum computers are going to allow us to do things that we can't really do with regular computers, because a regular computer, again, you have to process a calculation, and if you can do 1,000,000 of those in a second, then, if it takes you 1,000,000 computations, then you can do it in a second. But there are some things that are much harder than that. If you think about multidimensional computations, if you think about things like factoring numbers, large numbers. I have a huge number and I want to know what are all the possible numbers that you could multiply together to get that number. So factoring a number into its composite primes, for example. Those are super hard problems to do with regular computers, but they are the absolute targets of what we want to do with quantum computers, because rather than take 1,000,000 years, I'll do it in a second. And a second is a lot shorter. Well, quantum computing poses some very unique threats to computer security in particular, and that's really where a lot of the focus is today. The primary one is that quantum computers can do things that regular computers can't. They can do them really quickly. Like if I have a large number that's a public encryption key and it is comprised of two large prime numbers, the security around that entire infrastructure is that no classical computer can break that down into its prime constituents in less than 1,000,000,000 years, let's say. And in 1,000,000,000 years, no one's going to care if that data is stolen. With prime numbers and quantum computers, however, they can break those down in a second. And so all of the technology that we use to encrypt network traffic, SSL, TLS, HTTPS, those are the things that people think about, whether it's on the government side, whether it's on the commercial side, all of those communications are going to be instantly susceptible to cracking as soon as we have quantum computers big enough to factor those numbers. And that's why people are very concerned about it. Arvind Krishna, who is the head of IBM's research on the quantum side, recently said in a panel, I believe in May, that any organization that wants to make sure that their current data is safe for more than 10 years should immediately start looking at quantum-proof encryption solutions. And that tells you, because IBM is on the forefront of a lot of quantum computing development, that they know that the threat is very real.